I welcome you all to the Spark Research YouTube channel. This is Dr. Vichan, Assistant Professor in the Department of ECE, and this is the 10th session of this particular GATE 2026. So, let me tell you, the organizing institute for GATE 2026 is IIT Guwahati, and we are talking about this course Electronics and Communication. And in this, we are trying to talk about the question and answer in the detailed analysis which has been asked in GATE 2026, and currently we are talking about this course signal and system, and in this session we are going to take the question which is closely related to the Fourier series. And here is the syllabus for your course networks and signal and system, and if we'll see here, the parts of the signal and system are here, and in this Fourier series is here, right? So we are going to take the question from this continuous time signals, that is Fourier series. So let's take the question now. Here is the question number 37. A continuous time signal xt is real, periodic, and with period t. So already it has been given that xt signal is a real and a periodic also, right? And satisfies the Dirichlet condition also. Okay, the Fourier series representation of xt is equal to this, and xt satisfies the following: x of t minus tau t by tau 2 is equal to minus of xt. For any integral m, which of the following option is correct, right? So xt is already given here, right? And now they are telling that this condition will also hold, right? X, if you are shifting by minus t by tau, then it will be minus x of t. Then they are asking about the coefficient. Coefficient means they here, see here, a of n. So they are asking about the value of this coefficient if it holds this condition, right? So as per your answer key, your answer A is correct, that is A to M is equal to 0. So let's see. So first of all, since it is given in the question that like x of t minus tau t by tau is equal to x of minus t, so first shift your signal, right? So x of t minus tau. So here whenever x of t minus tau you are shifting, just you have to multiply by this x of t minus tau first. So shifting, and then after shifting you can the use the exponential property and write like this. So e to the power a into b, something like that, then e to the power a minus b, you can write like that, right? And after writing this, you can use this e to the power theta is equal to sine plus j cos, right? So using that property you can also write like this, and after writing since in the question itself given that x of t minus t by tau is equal to, we can rewrite this the Fourier in the form of the Fourier series, and here based on our assumptions, right? And in the question itself it is given that if you are shifting by minus t by 2, then it will be x minus of xt. So here finally we are going to use this equation. So here we will use this here, and then whatever the equations that we got it, that is x of minus t finally here, and both if we'll equate now, we will get the coefficient relation in between the coefficient, and this condition will be true only if this will satisfy. So now further, in order to satisfy this, you can check the values of the m, that is equal to twice of m. So here in order to vanishes the value, if it is, if only it will be true if your a to m will be equal to 0, right? And in that case, if m is any the even numbers, then definitely it will also true, like it will be 0. And similarly for odd, like if n is equal to 2m plus 1, odd numbers, in that case also minus 1 to the power 2m plus 1, and that will holds the minus 1, right? So again this is true. So it means that your A to M will always be 0. Means the harmonic, the all the harmonics, the even harmonics will be 0. Okay, so your answer is in a different manner. Here you can retry to understand. So this condition is given here, and this is your exactly x of t. So x of t is given, and then this condition, two things are given, right? So x of t, that is this, you can rewrite. So this is nothing, this is the actually how can we write the Fourier series for any function, right? X of t, that is an e to the power j omega t divided by tau, and this t is the period, time period, right? And integrated from minus infinity to plus infinity, and an is your coefficient, that is the major point of concern here, right? So this is suppose your x of t, and then whenever you are shifting by minus t by tau, so this is the your shifted, and then further you can calculate, find out the x of t minus tau here. So once you will get the t minus tau, so here we got the t minus tau, then you can directly equate it as per the question is given here, max of minus t by tau is equal to t. So use these properties and put the values left side and right side, and automatically you will get that it will holds only if this a n minus 1 to the power n is equal to a minus of a m, and this will be true only if like this condition will hold. And when will this condition will be true? So minus 1 to the power twice m is equal to 1. So here a to m will be equal to 0 for all even harmonics, right? Similarly, you can put m is equal like n is equal to twice m plus 1 for odd numbers. Again, it will also true, means all the here all the even harmonics will be 0, right? But the odd harmonics may be not 0, right? So these are the 0 values, so that is why your a to m will be 0, right? So here is the basic idea about the Fourier series. So here you can like what is the meaning of the Fourier series. So suppose this is your x of t, and so whenever you are trying to write the Fourier series for your any signals, then it is nothing, the the combination of different signals. Different signals means here actually this is a fundamental, then the higher order frequencies, then the frequencies will keep on increasing, keep on increasing, keep on increasing, and the amplitudes will decrease, decrease, decrease. So you can say that this sinusoidal, this x of t is the addition of this and all these, right? Something like that. Some white light is the addition of the Vibgyor light, na? Like that, very similar to that, your signal can be represented as the addition of all these signals, right? So that is why the Fourier series you can write in this manner. So, and how can you write mathematically this one? So f of t you can write a naught by 2 here for fundamental one, and then plus this is the even harmonics and then odd harmonics, right? So a n cos of, and a n, a naught, b n all are the coefficient, and then cosine function and the sinusoidal functions, right? And after adding all these the your functions, if you add all this, then again you will able to reconstruct the original message. So this is the original message, that is your x of t. So x of t is nothing, the addition of all these signals. Okay, thank you to join the session. So play today, stay healthy tomorrow, and learn for a lifetime.